Day 3, Problem 1. A 40-foot ramp has a horizontal length of 36 feet. Question A, sketch a diagram. And then question B, use the Pythagorean theorem to find the ramp's height. So question A, we want a side view of a ramp that might look like a right triangle like this, where there's a 90-degree angle in that corner. Now we're told that it's the ramp that's 40 feet. That's this side of the right triangle, 40 feet. And that it has a horizontal length of 36 feet. And so that's this side of the right triangle. And the side of the triangle we do not know is over here. That's the ramp's height, which we're going to figure out for part B of this problem. So in part B, the Pythagorean theorem is a squared plus b squared equals c squared. The variable a is the shortest leg of a right triangle, which is this side here, the one we do not know. We can put an a in the diagram for that side. Variable b is the other leg of the triangle. That's the 36. And the variable c is the hypotenuse of the right triangle. That is the 40. So here's what our equation looks like when we've substituted values in. We want to solve for this variable. So first, let's isolate that a term. That means we need to remove the plus 36 squared. So subtract 36 squared, subtract 36 squared. The a squared can come straight down. 36 squared subtract 36 squared is 0. And that's equal to, now over here on the right side, 40 squared subtract 36 squared is what we need to figure out. (40) squared subtract 36 squared. 304. So a to the second power is 304. Let's now figure out a by doing square root. So the square root of a squared is equal to the square root of 304. That means a is equal to, now let's find the square root of 304. Square root 304. That's 17.4. The next digit is not 5 or higher, so we'll leave this as a 4. 17.4. The variable a is written here in the drawing, which is representing the ramp's height, and so this value is the answer to the question about ramp's height, 17.4 feet. Now, Day 3, Problem 2. You invest $750 in a fund that earns 3.25% interest compounded monthly. If you make no additional deposits or withdrawals, then what is the value of the investment after 3 years? Here is the compound interest formula. So let's solve this for A, the amount of money in our investment after 3 years. P is principal. That is the $750. The letter R is interest rate, but it's important to always put this in as a decimal. And right now, this is given to us as a percent. So we need to take the 3.25% and change that to its decimal form. That can be done by moving the dot 2 spots to the left. That becomes 0.0325. Now the letter N, the number of times the interest is compounded. We're told it's compounded monthly. That means 12 times per year. In the exponent, the letter N is 12. And now the letter T, the time in years that our investment is increasing. We're told this occurs for 3 years. so t is 3. We can simplify this exponent up. 12 times 3, that's just 36. That'll be a little faster to type in when it comes to that. And so let's see what this makes on the calculator. $750 times 1 plus 0.0325 divide by 12, close the parenthesis, exponent 36. $826. Looking at the next number, that is 5 or higher, so we round this up to 70 cents. So $826.70.